Well, hello students, how are you? As you remember, last tutorial we have seen some basic concepts of function and different types of function. And today, let us see some important types of functions, their behavior and the nature of those functions. From this function, polynomial function is one. So first let us see the definition. As you see in this, polynomial function of a degree n is the variable x, a function defined by p of x given is equal to nxn plus an minus 1 x the power of n minus 1 plus, and it will continue up to a 1 x plus a naught. This means there is an minus 2 x the power of n minus 2, like that. But here, where each ai is a real number, but n different from 0, and n is whole number. N is whole number. So n is called the leading coefficient. N is the degree of the polynomial. And a naught is called the constant term. This is a constant term, and this is a leading coefficient, and this is a degree of the polynomial function. So these n's are natural number, or we can say whole number, because 0 can be a degree of any. 0 can be. So this n is whole number. This n is whole number. This is the standard form of a polynomial function. A polynomial function. Remember, integers are such like minus 2, minus 1, 0, 1, 2. No decimal or fractions. Positive integer would be the only positive integer would be the degree of a polynomial function. A polynomial function is a function of the form such like things. This n must be a positive integer. A positive integer. But here I will ask, is 0 is positive integer? I disagree. But some books and some mathematician says like this. Rather than this, I think it is better to say whole number. So n minus 1, these s are what? Coefficients. The coefficients. So the degree of a polynomial is the largest power on any x term in the polynomial. So in order to say this is the leading coefficient of the polynomial function, that coefficient must with the highest degree. For example, let us say y is equal to x plus b. Here, what is the degree of the polynomial function? Y. What is the coefficient? A. The constant term? B. By the way, this type of function have a special name, which you call it linear function. Do you remember this? Y is equal to x squared plus bx plus c. What is the degree? 2. So the leading coefficient is still a. That's why a is different. That's why we restrict a is different from 0. By the way, what about if a is equal to 0? It will be 0, and this quadratic equation will be changed into a linear equation, such like this. So if a function is degree 1, we can call it linear. If it is degree 2, we can call it quadratic. If it's degree 3, we can get cubic, and it's degree 4, you can call it quadratic. The largest exponent within the polynomial determines the degree of the polynomial. By the way, when we did the graph of a polynomial function, their graph is continuous and smooth. Continuous means there is no break here, or there is no hole here. A smooth means when you see the curve one is smooth. It is not a sharp corner. Sharp corner. Look this. This is sharp. It is not a graph of polynomial function. A graph of polynomial function. And you can see in the module there are different types of graph of polynomial function and how we can sketch. You can refer to the module. I will give you the module at the end of the course. So polynomial functions are also smooth with round turns, and graph with pointers or curves are not graph of a polynomial functions. The next point, and very important point, is zero of a polynomial function. By the way, zero of a polynomial function means, in other words, find the solution set of the given polynomial functions. For example, if you wanted to find the zero of this function, means 2x plus 5 is equal to 0, 2x is x is equal to this. By the way, this is a polynomial function, which degree 1, leading coefficient 2, and constant term 5. So finding the zero or finding the solution set of linear polynomial function is very easy. What about finding the zero of a quadratic functions? There are different methods, but it is better to use a general formula. Given x squared plus bx plus c, x is equal to minus b plus or minus b squared minus 4ac over 2a. Now, if you remember, in chapter 2, I think we have seen complex numbers. So every polynomial function every polynomial function which have a degree 2. In other words, every quadratic equation have a degree 2 under the set of complex number. So it is a matter of identifying. My B, A, and C, and use this formula. So it is very easy. It's very easy. But here we'll focus how to find the degree, the polynomial function which have more than two degree. For example, degree 3 and above. If it is possible to judge the given polynomial as a product of degree 1 and degree 2. This is, by the way, the best. But if it is possible, then we will use this. For all numbers a and b. If a and b is equal to 0 this means a is equal to 0 or b is equal to 0 or both a and b equal to 0. We can find the solution set. So using these pointers, we can find the solution set of a polynomial which have degree 3. For example, find the 0 of x cubic minus 4x. By the way, it is very important, especially for electrical electronics students. I think for your major course you will get, for example, there are two types of connection or combination of resistors. So at that time you will get what an equation which have a degree 3, which have degree 4, such like that. So at that time it is a matter of changing variable. In your major course, the variable may be R resistor, R cubic, like that. So if you know this, that will be easy. For example, look here, x cubic minus 4x. So take out x as a common, then x will be x squared minus 4. Then this is the product, and also x squared minus 4 means x squared minus 2 squared, and x squared minus 2 squared is x plus 2 times x minus. So here, by the way, this is a product of three things: x times x plus 2 times x minus, which is equal to 0. Don't forget, this is degree 1, this is degree 1, this is degree 1. This is very easy. So the first solution will, by the way, this will be 0 when x is 0. So now I get one of the solutions set at 0. When it will be 0, if it is a minus 2, it will be 0 also. What about this? So this solution, this polynomial function have the solution set 0, minus 2, 2. Students, bear in mind, all polynomial function have at most, we may have, can I say may have, a solution set at most which is equal to its degree. For example, this is a polynomial function, by the way, the constant term is 0 and the degree is 3. And what is A3 means? The leading coefficient is 1. What is A2? A2 is 0. There is no x to the power of 2 here. So, it may have what? At most 3 solutions. It does not mean that it has always 3 solution set. So this is very important point to you. And let us add some examples. For example, look here, x cubic minus 5 square minus 2x plus 10. And let us use a grouping method, x squared minus 5 squared as a group, and minus 2x plus 10 as a group. Let us take out a command for here, but there is a type error here. Yeah, this minus will be here. Yeah, please correct it. This minus type error, this minus will here, and then it will be 2x minus 10. 2x minus 10, yeah. X squared into x minus 5 when I take x squared here. So minus 2 times x minus. Yeah, now it is correct. And the third term. So it is the product of two things, like what I've said, the product of this. Assume this is a, and this x minus b is 0. If a times b is equal to 0, either a and b are 0, or either of the two 0. So by using that law, x squared minus 2 is equal to 0. At that time, we will get this solution. X squared is equal to 2, x equal to 2 plus or minus root 2. And when we say x minus 5 is equal to 0, x will get x equal to 5. Therefore, this is the other method to find. By the way, based on the nature of the polynomial function, there are different approaches. To solve them. And the usual one is rational root test. As the name indicated, rational means, I think you know what rational number means, when a number which is written in the form of a over b, but b different from 0. So, if you are given a polynomial function, a n x n plus n minus 1 x n minus 1 plus like this, and has integer coefficients, then every polynomial 0 of p is of the form p over q. Here, what is p? P is the factor of the constant coefficient, that means a naught. Q is the factor of the leading coefficient, but p is the factor of the constant term. Rather than say this coefficient, say please constant term. It's type error, my students. So, after finding this, we'll follow some steps. Let us see by example. Example, find x cubic minus 3x plus 2. Since the leading coefficient is 1, any irrational 0 must be divisor of the constant term 2. That means, now, p over q is 2 over 1. 2 over 1. So, take the factor of 2. The factor of 2 is plus or minus 1 and plus or minus 2. So, we test each of these possibilities. What does it mean? Plus minus 1 will be the solution of this, plus 1 will be a solution of this. I am not saying that minus 1 or 1 is a solution set. I say will be. That is why the method is called rational root test. And test again by 2 and test again by minus 2. By minus 2. This is possibilities. By the way, there are 4 possibilities. So, test it. P1. Oh, bingo. We will get 0. Minus 1 is different from 0. 2. different from 0, minus. So the solution set is what? 1 and minus. 1 and minus. But it is very tedious, by the way. It's very tedious. Okay, finding the 0 of this. 2x cubic plus x squared minus 13x plus 6. By rational test, take p factor of constant term 6 over 2 is 3. Is that? Yeah, 6 over 2. So takes the constant term 6 and the leading coefficient 2. So the factor of 6 over 2 is 3. So list out the factor of 3. These are the what? The factor of? Yeah. Thus the possible rational 0 of p. Okay, I made a mistake here. Don't simplify here. Yes. Yeah, the factor of 6 over factor of 2. Take as this. So the factor of 2r is 1, this, and this. So we'll get what? The factor of 2, 1 over 2, 2 over 1, 3 over 1, 6 over 1, and 1 over 2, 2 over 2, 3 over 2, 6 over 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, 60, plus, because this is plus or minus. Simplifying the fraction and eliminate the duplicate, yeah, simplify. But for example, here we'll get 1, so there is here also 1, and 6 over 2 is 3, so eliminate the duplicate 1. So the possible zeros are, the possible rational 0 are these. So I will give you exercise which rationals give 0. Please test it in your homework, as in your home. If all rational tests can't give 0, and I will add 1 point. If all rational tests can't give 0, what will be the solution of the polynomial? Please refer the module. There are different methods. And the classwork is the class. Which rational gives this? And if all rational tests can't give 0, what will be the solution of the polynomial? What will be the solution of the polynomial? And in addition to that, please refer some different mathematical books, how to solve a degree 4, degree 5, and such like things. If you have any question, put your questions in my email and the Telegram channel. And here is an activity. Please exercise it. Please exercise it. It will very important to you. And the next important function is exponential function. Exponential function. The exponential function is a function which is written in the form of like this: f of x equal to b the power of x, or usually y is equal to b of x. This is function. But in order to be its function, we have to put our restriction. Our restriction is b is positive constant other than any real number. Why? For example, can it be negative 1 or can it be negative 2 is the base? It's impossible, because now we are seeing exponential function, not exponential terms. Minus to the power of x can be exponential term, but can't be function. Why? Because minus 2 square b the power of x, or y is equal to b the power of x minus 2 square will be what? 4. 2 square will be what? 4. So what is the reason? B is a positive constant. Please refer it. X is any real number, by the way. X can be any real number. X can be a real number. Here are some examples of exponential functions. To the power of x, base is 2. This base 10. The base is what? 3. The base is 3. And there are law of exponent. Let n be positive numbers and let x and y be real numbers. Then these are very important points. B the power of x times c, take one of the base and add their exponent. If it's divided, use like this. We can. By the way, here the rest one is b the power of minus x means is equal to 1 over b the power of x. Don't forget it. B the power of 0 is what? 1. 0 can be a base. Impossible. 0 the power of 0 is, I think, undefined. So the value of f of x is equal to 3x when x is equal to is like this. It's very trivial. And there is a power of minus 2 means 1 over 9, because I said 1 over this. And this means this. It is very easy, by the way. And do you know number e, by the way? E means, by the way, to the 0.718 to 822, like that. So this is called natural base. So the function is the power of x is also a function because e is number. It is a number between 2.5 and 3. 2.5 and 3. So every law work for a natural exponential functions. And the graph seems like this. For example, is a power of minus 2 means 1 over is a power of 2 is a power of 1 means e is a power of 0 is 1 and is a power of minus 1 is 1 over e is a power of 2 means the square of this round to the nearest 10,000. You can round it like that. By the way, you can find in your calculator. And logarithmic function is another type, some important functions. By the way, logarithm is the inverse of exponential functions. Look here, for x greater than 0 and 0, 0 is less than a and different from what? Y is equal to 0 less than a means in other words a greater than 0 and a cannot be 1. Y is equal to log the logarithm of x in base b. When I read it, the logarithm of x in base, the logarithm of x in base a, if and only if we can change into exponential function. So it will be x is equal to a the power of y. A the power of y. That's right. It's the inverse of exponential functions. Sorry. So there are some properties. The logarithm of a the power of 1 is equal to 0. Since a the power of 0 is this, the logarithm of a in base a is 1. The logarithm of such a the power of x in base a is this, because a the power of x is equal to the power of a, we will get what? X here. And the logarithm of x in base a is equal to log a log y, then x is equal to it is true when x and y is equal to 2. Inverse properties, this is one-to-one property. For example, let us solve this. What is it? Logarithm of 6 in base 6 is equal to x, so it will be 1. This is very easy, and I think you will see you have seen in lower grade. It is a matter of what? Remembering. Do you know common logarithm? A common logarithm means a logarithm which is base 10. For example, if you wanted to find logarithm 7, I think in your calculator you will touch simply log 7. So you will get some number. So common logarithm is means base 10. If there is no base given, you have to know the base is 10. That is why our computer and our calculator manipulate by using logarithm of base 10. And natural logarithm is a logarithm which is base e, and it has a special name. We call it ln. Ln x means always you can change into logarithm form. Logarithm of x in base a, This is a graph of ln x, by the way, from your module and different mathematics book. You can also observe the graph of exponential function, the graph of logarithm function, and you can find ln value in your laptop or calculator. And property of natural logarithm, ln 1 is equal to 0. Why? Ln 1 means the logarithm of 1 is the base e, that's 0. So ln e means 1. Ln ex is x, and e the power of ln x is equal to x. These are some properties. So ln means, by the way, the logarithm. These are the inverse property and others. The next and the third one, I think, is that the third one? The fourth one, trigonometric function. In mathematics, the trigonometric function is also called circular function or a function of an angle. They relate the angle of a triangle to the length of its side. Trigonometric functions are important in the study of a triangle and modeling periodic phenomena, among many other applications. For example, in your major course, there are sine wave, cos wave. The application is here, the same tool. This. So the most familiar trigonometric functions are sine, cosine, and tangent, and they are reciprocal functions. The reciprocal function, let us see this. The trigonometric function in a right triangle, there are exactly 6 possible trigonometric ratio or function. A Greek letter such as theta or phi will now be used or represent the angle. Assume this is theta. So sine theta is equal to opposite over hypotenuse. And cosine, tangent, I think you are familiar for those. So simply, what is angle? This is an angle, by the way. If you rotate one ray to the direction of counterclockwise or counterclockwise, you will form an angle. So this terminal side, initial side, this vertex, and how we measure? Now we measure. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. There are two common ways to measure angle, in degree and in rad. By the way, they are unit, I think. They are unit. But the apparatus used to measure an angle is protractor, I think. Protractor. And there are different other units, the second, degree, house, so you can like that. So, but the usual one is degree and radian. And let me show you the relationship. 1 rad means this degree. 1 radian means 57.3 degree. What about rad? 3 rad, 5 rad. Let's continue. Another way of measuring angle is put here. You can change rad to degree, degree to rad. It's very easy, by the way. It is very easy, and it is very easy. For example, you can convert the degree to radian measure, and the vice versa here. Okay, hyperbolic functions. For this reason, they are collectively called hyperbolic function and individually called hyperbolic, sine hyperbolic, cosine, and so on. So the definition, sin x is equal to ax minus e the power of x over 2. I think now you know what e means. So these are called hyperbolic function. The hyperbolic function satisfies a number of identities that are similar to well-known trigonometric identity. So sin of minus x is equal to this, and this is called locate, and you can use it. Example, prove this. I left B as exercise, but let us see. A solution. Show that this is this. So this means this ax plus is a power of minus is all square minus since is like this, and after this it is a matter of algebra. The matter of algebra. That time 4 over 4 will be what? Because is a power of x plus is a power of minus x is a power of x minus, they will cancel each other. Here is minus, and 4 over 4 will get y. So the definition is very important. The definition is very important. And here are some exercises. Please exercise it. Thank you very much. This is all about chapter 3, which is a function. If you have any doubt, comment, question is put your question, comment, and other any things in my email and my Telegram channel. Use this phone number by to Telegram channel. Thank you very much. Be safe. See you.